Hi, this is Mr. Ing for Algebra 2A quiz number 17, February 27, 2015. I'm going over the multiple choice questions, each worth 2 points. Remember, the multiple choice work is not needed. Number 1, use the substitution method. So if I already know that Ken needs to solve it by the substitution method, so I'm going to take this problem and kind of predict what they're looking at. It looks like right here they try to substitute in for the value of x. So that means I have to solve for x. Solve for the y variable. Solve for the y variable, because it looks like they're substituting into that second equation. So I want to get y by itself. I have y equals 2x minus 5. And I notice that y is solved here correctly. Notice how here y does not equal negative 2x plus 5. Algebraically, that would have been incorrect. Let's just say you did it the other way around. Let's just say you thought it was choices 3 and 4. You're solving for the x variable. If you solve for the x variable, this would have been x, sorry, divided by 2, then you would have gotten x equals 1/2 y plus 5/2. So I don't see that. There's 5/2, but not a positive there. Let's just say you took the second equation and you solved it for x. I don't see that there either. So the first question number 1, the answer is choice number 1. Question number 2, which point is in the solution set of y is less than or equal to 2x plus 1 and y is less than negative 3x plus 1 or plus 4? You're just looking for a problem where 1, 1 is a solution for both of those. So notice my check marks. That's for the first equation inequality and the second inequality. 1, 1, that would be 1 is less than 2 plus 1, which is 1 is less than 3. That's true. And if I do it to the second one, 1 is less than or equal to negative 3 plus 4, which gives you a positive 1. 1 is equal to 1. Number 3, how I did this problem is it says write a compound inequality that represents. So I recognize that they're separated like boat oars. Oars is my keyword. And I have numbers that are less than negative 3 and greater than or equal to 1. And that's only choice C. So just take your graph and then make inequalities. Question number 4 says choose a statement that is true about the given quantities. So our quantities are just basically column A and column B. Column A, it says f of 3, so you take 3, and the only thing that actually works, 3 is not smaller than or equal to 1, so don't use the top, use the bottom one. 3 is greater than 1, true. Substitute in 3, becomes negative 3 plus 9, which is 6. F of 3 equals 6. Same thing for B here. F of 2, take the 2 where it's true, it's here. So I substitute in 2 and I get 4. So if I compare these two answers, 6 and 4, 6 is greater, so it means column A is bigger. Choice A is the answer. Question number 5. Which point is in the solution set of the system of inequalities shown on the accompanying graph? So you're just trying to find it in the double shaded region. So let's just say you've picked 3, 3. Let me show you why 3, 3 is not the correct answer. 3, 3 is actually the point of intersection, but it's on a dotted line. On a dotted line, it means it's not a solution. Do not include it. Notice clearly 5, 2, 3, 4, 5. 5, 2 is in the double shaded region. Question number 6, solve the compound inequality and graph the solution set. So essentially what you're doing is you're doing two separate problems. Let me show it to you. 2x minus 4 is less than 4. There's number 1. And here's the second one. Notice I'm using my finger to cover it. Negative 8 is less than or equal to 2x minus 4. I separate and put it back together. And you'll get x is less than 4 and x is greater than or equal to negative 2. There is my compound inequality, and that's letter choice A. Another way of doing the problem, let me write it out here, negative 8 is less than or equal to 2x minus 4 less than 4. So this is a second way of doing the problem. In your inequalities, just draw some lines. So I'm going to add 4 to both the left and to the right. This gives me negative 4 less than or equal to 2x less than 8 divided by 2 on all left and right. Negative 2 is less than or equal to x less than, sorry, it's less than 4. So notice how you'll get the same two solutions. Question number 7. Remember I asked you guys to change it to say absolute value of 2x plus 3. Wasn't sure if that was very clear. So the absolute value signs are isolated, which means you split it. Notice how they're exactly the same, 19 greater than or equal to 2x plus 3. Now, the argument, one is positive, one is negative. Here I can drop the parentheses, subtract 3, divided by 2, I get x is greater than or equal to 8. Negative sign, divide both sides by a negative. When I divide by a negative, I flip the inequality, subtract 3, divide by 2, I get x is less than negative 11. Now, remember, the keyword or here is when absolute value is greater than a value or equal to 19, you have to put the word or, and here's the reason why. Remember that story I told you guys, when your interest in someone else is great, then you need to split up. So my solutions would be x is greater than or equal to 8, or x is less than or equal to negative 11. Question number 8. Tell whether the lines for each pair of equations are parallel, perpendicular, or neither. I'm just going to take each of those and put those into slope-intercept form, and then I just compare my slopes. I notice that my slopes are not the same, so they're not parallel. They're not negative reciprocals. Negative reciprocal of 1/4 is negative 4, or this negative reciprocal is negative 4 over 7. That's not that, so the answer is neither. Question number 9. Write an equation in slope-intercept form from the given information through 2, 6, and perpendicular to y equals negative 3/4 x plus 1. Negative 5/4 x plus 1. So I have the slope of the first line, that's m1. And remember, my slopes that are perpendicular, their product is negative 1, or essentially negative reciprocals. And that becomes, your second slope is 4/5. So 4/5 and negative 5/4, these slopes are perpendicular. Now I just take the other point, so I have a point and I have a slope, and then I can just put that into point-slope form. Slope is 4/5. My y1 value is 6. My x1 value is 2. I'll distribute there. I'll add 6 to both sides. Here's my 6. The reason why I changed it to 30/5 is because I'm going to have to add it to the other constant, negative 8/5, which gives me 22/5, and that's their choice, C. Question number 10. Tell whether the system has no solution, one solution, or infinitely many. So no solution means that they're going to be parallel. One solution means that they're intersecting lines. Infinitely many means they are the same line or coinciding lines, which means they essentially have the same slope and the same y-intercept. So I'm looking at this problem here, and I notice that my slopes are the same. So if my slopes are essentially the same, I know it can be parallel. It can also be coinciding, but it can't be intersecting, because intersecting lines have to have different slopes. I also notice here that my y-intercepts are different. So if they're different, that means that they're parallel. They're not coinciding. Coinciding just means same exact line. So if they're parallel, it means it's no solution. A is my answer. Question number 11. What is the vertex of the function y equals absolute value of negative 3x plus 2 minus 4? What I essentially did there was I factor out a negative 3. When I factor out a negative 3, I get negative 3 times quantity x minus 2/3. What this does is that your a value is 1. Here's in vertex form. My x value there, or my h value, becomes 2/3. And my k value is negative 4. I need to make that extra credit, so if I don't change that in areas, please let me know. Question number 12. This was a 2 points for each box. So the domain inequality means it goes from left to right. And the first thing I touch here is an arrow. There's your hint, which means all the numbers are in this direction. And if I go here, the last thing I touch is another arrow, which means all the positive numbers. So essentially that means all real numbers. The explanation for interval notation essentially means the same thing. Anytime you see the arrow, that's the first thing you touch going from left to right for the domain. This means you need all of the negative numbers. And the last thing you touch over here is the arrow, which means you need all of the positive infinity. So here's the chart. I saw a lot of mistakes where a lot of students were changing the parentheses to brackets. Remember, anytime you have infinity, it's always going to be parentheses. Question number 13 says solve by elimination. So you must use elimination. So here are my two equations. Now I notice I can't add the y values to be 0. I can't add the x values to be 0 or to be eliminated. So I take the first equation, I write the x first and the y second. I still don't have anything. But I notice here that I can just multiply the equation by 4, and then I can eliminate my y variable. So if I distribute the 4 there, I'll get negative 12x plus 4y minus 12, and I get a negative 2x minus 4 equals 26. That's the second equation. Now I can just add down. My y's are eliminated. I get positive 14. Divide by negative 14, x equals negative 1. If you got to solve one variable there, I gave you 3 points for solving one variable. Take my x equals negative 1, substitute to an equation. I did the first one. That's positive 3. I don't know why a lot of students miss this part right here. Remember, when you're subtracting 3 from both sides, that becomes a negative 6. Y is negative 6. Negative 1, negative 6. Question number 14, solve for the equation or formula for the indicated variable. The indicated variable is 4t, which means you get t by itself. I did ask you guys to add this part, x equals, that's an s, letter s, minus 5, the number 5, r squared t. So you might have been intimidated by the exponent. Remember, when you're solving for variables or just solving in general, you're doing the opposite of order of operations. In this case, this is a positive, so I'm going to subtract s from both sides. Here, each of the math operations are multiplication, so I'm going to divide by negative 5rt, negative 5r squared to both sides. This is all eliminated. You're just left with t equals x minus s divided by negative 5rt, or the negative sign should be out here. Here's another explanation of some of the work. A lot of students try to add 5rt here, but you can't do that because there's multiplication there. The opposite of that is division. So here's another way of solving the same problem. Looks a little bit different. I want to double check for some students' work. So then I subtract s from both sides. You can divide by negative 5s, and these will cancel. And then I'm going to divide by r squared on both sides. If I split that, that's an x over negative 5, and negative s over negative 5, which becomes a positive. Distribute the r squared. And it's essentially the same problem. The only difference here between the two is that in the numerator it says s minus x and x minus s. S minus x, x minus s, and no negative in the denominator. Question number 15 is 5, negative 2 a solution of the system. Show your work, why or why not. Here's my work. If I take 5, negative 2 and substitute to each of the equations, it'll be true. Here's the reason why it is a solution. It's a solution because it's true for both of my equations, right? It's that point of intersection. Question number 16. Explain why the inequality 3 less than x less than 1 has no solution. If you guys if you graphed this, I essentially gave you 2 points for the correct graph and 1 point if you just tried the problem. So you might be thinking, well, what does a graph have to do with this? Well, remember, this is an and compound inequality, and this picture shows or, so it doesn't make sense, right? So that's the reason why I didn't give you full credit. But just think about it. Think of counter examples. A lot of you did not explain well. If you pick a number here, let's just say 0. 0 is less than 1. But is that 0 greater than 3? That's false. So that any number that you pick has to be between 1 and 3. And that number can't be both smaller than 1 or less than 1, and can't be greater than 3. Question number 17. I'm solving this system of inequalities by graphing. Notice how I'm going to get the second one into slope-intercept form. I added y to both sides, then subtracted 2. I get y equals x minus 2. Once you graph it, y equals 2x plus 1. I have my y-intercept of 1 here and a slope of positive 2, so I'm going to go down 2, left 1, negative 2, negative 1. And you can actually take that all the way down. My other equation is y equals x minus 2, so it has a y-intercept of negative 2, down 1, left 1, or down 1, left 1, down 1, left 1. And their point of intersection is negative 3, negative 5. Now, if you graphed it correctly, you graphed both correctly, but you don't get the order pair negative 3, negative 5. I gave you 3 points out of 4. If you graphed one of those correctly, I gave you 2 points. Question number 18. Solve this question by substitution. So essentially, you have x minus 2 equals 2, and y equals 2x plus 1. Well, already this is a quick substitution problem. Every time you see y, write 2x plus 1. You see the variable y, substitute in 2x plus 1. Don't forget this negative sign here. That'll get you negative 2x. Distribute that, we give negative 1. Combine like terms, this is a common mistake right there. This is a 1x minus 2, which gives you negative 1 or negative x. Add 1 to both sides. You'll get x equals negative 3. And then substitute that into one of your equations, and you'll get y equals negative 5. Now, if you think about it, if you're using the same systems, you should get the same answer. And that's why here in 18, my solution is negative 3, negative 5. And my point of intersection for question number 17 is negative 3, negative 5. So if you solve for one variable correctly, I gave you 3 points. 2 points if you're going in the right direction, meaning you knew to substitute but maybe forgot the distribution or combine like terms mistake. Last page. Number 19, graphing a piecewise function. Graph, make sure you label all intercepts and endpoints of the piecewise function on the graph, essentially. Okay, so g of x equals 3. This is a horizontal. G of x equals 3. Let's just say you, remember you forget, change that to a y. Y equals 3. And you can just make a table of values. All your y values are 3. You make up the x values, and you should have gone that it's a horizontal line on the y-axis at 3. Okay, what does it mean when x is less than or equal to 0? Well, here's x at 0. Essentially this line where my pen is, right? And you need numbers that are smaller. That's to the left. Now, the reason why you go left is because those numbers are getting smaller on the x-axis, negative 1, negative 2, negative 3. It's a closed circle because I have a less than sign. And my endpoint is 0, negative 3. It's a little hard to see. Let's graph this next one. G of x equals x. G of x equals x. Well, you can add some 1s and 0s that might help. If you add a 1 in front of that, that's your slope. And if you add a 0, that's your y-intercept. Essentially the same. So essentially I'm going from the origin, that's my y-intercept of 0, and a slope of 1, up 1, right 1. I have an open circle here at the origin because the inequality says x is greater than 0. So again, same thing. It's at the y-axis, right? Vertical line at x is 0. And you're looking for values that are greater than 0. That's going towards the right. So I gave you 2 points for graphing each of those correctly. Let's just say you had a mistake on your open or closed circles. That'd be a -1. Question number 20, solve in any method way that you wanted. I'm hoping you recognized that very quickly you don't have to manipulate or change any of the equations. You could have just added those and that would have gotten you 0y. So you have 3x equals negative 1. Divide both sides by 3. You get x equals negative 1/3. I substituted back into the top equation there. X equals negative 1/3. A lot of students had some issues right here. So essentially you're adding 1/3. So if you know you're adding 1/3 to this side, I'm just going to make that a fraction. Negative 4 over 1, and I'm eventually going to add a third to that, right? So I made it an equivalent expression. I want the lowest common denominator, which is 3. So I get negative 12/3. Negative 1/3 plus y equals negative 12 over 3, right? That's the same as negative 4. Remember here, this is the opposite of this is subtraction is addition. So you're adding 1/3 both sides. You just need to look at the numerators. Negative 12, positive 1 gives you a negative 11. Y equals negative 11 over 3. I gave you 2 points if you solve for one variable in that problem. Question number 21. Graph on the coordinate plane. Make sure you label all your intercepts. 3x minus 2y minus 7 less than or equal to 1. Add 7 to both sides. Put in slope-intercept form. Subtract 3x. Divided by negative 2 on the whole side on the right. That would be positive 3 half x. And that would become a negative 4. There's my negative 4 as my y-intercept. Up 3. 1, 2, 3. Right 2. It's going to be a solid line because it's equals to. Remember this inequality sign? If I've been circling that inequality sign for you, that essentially means you're not shading it. You know to shade it because there's an inequality. Well, how do you know where to shade? You pick a test point. The most popular test point is 0, 0. It's the easiest because zeros work. I substitute in 0, 0. I simplify. Is 0 greater than or equal to negative 4? That is true. 0, 0 is true on that side. You shade that. That means that's where all your solutions are. So if 0, 0 here is true, you shade that. If 0, 0 is false on that inequality, then you shade the other side. That would mean all of these are false and that would be true. But in this case, all my solutions are on the left. Okay. And my intercepts. I already have my y-intercept, so I just need to find my x-intercept. Make y equal to 0. You get 3x equals 8 or x equals 8/3. You get a point for solid or dashed. Point for correct graph, meaning if you graph this correctly going through negative 4, I give you 2 points. Point for shading and a point for having your intercepts. I hope this was helpful for you to be successful on your quizzes and tests.